In this video, we're going to talk about the inscribed angle theorem. So this is one of the four main properties, angle properties of a circle, and it is the inscribed angle theorem. So in the previous video, we discussed what a central angle is. A central angle is an angle where whose vertex is on the center and that angle corresponds to the arc by being congruent. The angle measure of the central angle is the same as the corresponding arc measure. For an inscribed angle is an angle whose vertex is on the circle. So for a central angle, the vertex was on the center. An inscribed angle, the vertex is on the circle. So if we come over here and we look at these pictures, if I look here, here's my vertex and here's my vertex. Which one of those is on the circle? Well, that's this one. This one is not an example of an inscribed angle because the vertex is not on the circle. So now, if I highlight my piece of pie here, and I think I can make let's do it this way. Here's my piece of pie, okay? Notice, here's my angle, and here's its corresponding arc. So notice that angle doesn't look the same measure as that arc, because with an inscribed angle, the angle is half the arc measure. So if my arc was 100, my angle would be 50 degrees. Okay? So if I go ahead and I look at some of these examples, looking at this angle, notice where the vertex is. The vertex is on the circle, so it's an inscribed angle. Inscribed angles are half of its arc measure. So since its corresponding arc measure is 78, half of 78 is 34 degrees. Okay? Number 2, again, my vertex is on the circle, so it's an inscribed angle. So it corresponds to arc 110. It's half of its arc, so x is 55 degrees. So number 3 is where it gets a little entertaining because I have multiple pictures in here. So I'm going to highlight where I have a number. So this arc is 122, and I'm going to highlight the piece of pie it corresponds to. So notice I want to find x first. So x is an inscribed angle because it's on, the vertex is on the circle. So it's half of its arc measure. So half of 122 is 61 degrees. And then if I try to find y is this crust and it makes this piece of pie. Notice my angle is 27 and it's an inscribed angle because its vertex is on the circle. So if I double that, I'm going to get y, because half of y is 27, so I just do the inverse of that, which is double. So 27 times 2 is 54 degrees. Okay? So now I want you to pause this video, and I want you to try to find number 5 without my help. And then unpause this video, and we'll go over it. So if I look at this, I want to find x first. So if I look at this piece of pie, it's an inscribed angle. So if my arc is 40, that means x is 20. Okay. So now if I try to find y, notice y doesn't make a perfect piece of pie. So I have to use this other piece of pie I haven't touched yet, my yellow pie. So I know my angle is 50. I know my angle here is 50, so its corresponding arc, which is all of this, is 100. And because this sliver is 40, what's y's sliver going to be? 60. So y is 60 degrees. Okay? So now if we go ahead and we look at this next one, it wants me to find x and y. And notice x and y don't have any numbers, but I see this number here, 50. So that's an inscribed angle because it's on my circle. So that means this arc is 100. So now if I look at x, notice x shares that same arc. So if arc is 100, then its corresponding angle is half because it's inscribed. And if I look at y, it also uses that same arc, which is also 50. So another thing you can think about, if an inscribed angles share the same arc, then these angles are all congruent. You don't need to know that to be able to figure out these problems, but it is nice and helpful. All right, last one. I want to find angle x right here. So put a little x right there. Pause this video. You try to solve this problem, see if you can figure it out, and then unpause and we'll go over it. So if I highlight this piece of pi, I know nothing about it. But I do know this arc is 121 and this arc is 92. I know all arcs in a circle add up to equal 360, so I can add up 121 and 92 and subtract it from 360, and I'm going to get this arc, which is 147. So now I know x is an inscribed angle because it's on the circle, so half of 147 is 73.5 degrees. Okay, go ahead and flip your paper for me, please. If I look at this next one, it says, what happens when an angle is formed between a chord and a tangent line? So remember, a chord cuts my circle anywhere into touches, but its endpoints are on the circle. And a tangent line touches my circle in exactly one place. Well, notice the location of the vertex of the circle. The vertex of the circle, the vertex of the angle. The vertex of that angle, well, it's on my circle. We've learned 2 vocabulary words so far. The first vocabulary word we learned was central angle. It's because its vertex is on the center. And the second vocabulary word we learned was inscribed angle. And the inscribed angle, your vertex is on the circle. Well, notice its vertex is on the center, is on the circle. So since it's on the circle, nothing changes. This is still an inscribed angle. So what happens? Nothing. It's still an inscribed angle. Okay? So it's just a weird looking piece of pie. If somebody were to come and cut a piece of pie like this, you'd think they're a little crazy. But here is my pie and my crust. That's how much pie I'm eating. Everybody can share the rest. So, since it's an inscribed angle, I know my angle is half of its arc measure. So half of 134, 67 degrees. If I look at the next one, here's my piece of pie. Notice my vertex is on the circle, so it's an inscribed angle. So x is 65 is half of x. So I'm going to do the inverse. I'm going to double it. So x is 130 degrees. So you go ahead and you pause this video and you try to find x on this problem. And then unpause it and we'll go over it. So the only number I see in this problem is 60, so I know I'm looking at this piece of pie. And if that's an inscribed angle because it's on my circle, then I know this arc is 120. So now let's try to figure out x. X is, let's use a highlighter. X is here. Now notice that's this piece of pie. So notice x's vertex is on the circle, so it's inscribed. So its crust is 120 degrees, so x is 60 degrees. Okay? These 6 problems below are examples of central angles and inscribed angles. Notice these problems, if it has a letter in the center, that means that's the center. So this would be the center. See this dot here? That would be the center. We're assuming that's the center, and that's the center, and that's the center, and that point right there is the center to help you solve these problems. There's one typo on the middle row, second column. this 88 degrees, you need to cross that little 88 degrees out. It's a minor typo. So I'm going to walk you through the first one, and then I'm going to pause this video, and you're going to try these problems on your own. You can then fast forward to check your answers, and then if you don't understand any of them, you can come back and you can watch those specific videos, those specific problems if you get one of them wrong. So first one I'm going to do together, it says find the measure of AOC. So AOC is this right here. Is it central or inscribed? It's central. So what do I know about central angles with their corresponding arcs? They're the same. So that's 76 degrees. So now it wants me to find angle ABC. Angle BC is this arc right there. Well, what do I know about this angle? Is it central or inscribed? It's inscribed, which means it's half of its corresponding arc. So half of 76 is 38 degrees. You are more successful at this when you ask yourself, what type of angle do you have? So go ahead and try to finish these problems. And again, when you finish, you can fast forward to the end to check your answers. Then you can rewind to any problem that you got wrong. And if you got none of the problems wrong, then you can move on with what you're supposed to do next. So if I look at this second example, it says to find arc BMC. That's this arc here. Well, that arc corresponds to this angle. And I don't know that angle, and I don't know that arc, so I got to go back to the drawing board. Well, what I do notice, because when in life you get stuck, you're always going to look for triangles. I see a triangle. So I know all triangle angles add up to equal 180. So I can do 45 plus 68 and subtract that from 180. I get 67. So then I can double 67. And that's going to get me 134 degrees. Why I'm doubling it? Because it's an inscribed angle, and the angle is half of the arc, so since I'm going in the opposite direction, I'm going to double it. So now I want to find arc BAC. So I'm actually going to erase this to help me see. All right, BAC, B to A to C, that's that. Well, I knew this arc we just found was 134, so if I want to find the remaining arcs, I can just subtract that from 360. That's 226 degrees. And if I do the last one, arc ANC, that's this guy right here. I know that arc there corresponds to this angle. 45 degrees is inscribed because it's on the circle, so that would be 90 degrees. Now, if I look at this next one, the only way I can solve anything is assuming all of these arcs are congruent. So I'm going to do 360 divided by 1, 2, 3, 4, 5, 6, 7, 8. So 360 divided by 8 is 45. So each of these angles is 45. Okay. So now it wants to find SOW, so change my color here. Oops. S to O to W, that's all of them except for 245, so I can do 360 minus 90. I'm going to get 270. And then I want to find WSN, W to S to N. That's half my circle. Oh, I'm sorry, it's not quite half. W to S to N. I went a little far, it's just these. It's hard to see it on my screen. That's there. So 45 plus 45 plus 45 is 135. And SNO. Let me erase some of these arcs here so I can see it. S, N, and O. Now that's half my circle, so that's just 180 degrees. Or I could do 45 plus 45 plus 45 plus 45. I'm also going to get 180 degrees. If I look at the next one, angle BDC, that's this angle here. It's an inscribed angle, so it's half of 94, which makes it 47 degrees. ABC, that's this whole arc here. So if that's 47 degrees, That means this whole angle, 58 plus 47, is 105. So since that's an inscribed angle, double it, I get 210 degrees for the arc measure. Now this last one is, this second to last one's kind of entertaining here. I see 105 as a central angle, so I know that's 105. And because it's a central angle, I know this is 75 because it makes a linear pair. So that over here is also 75. And if this angle is 56, I know it's an inscribed angle. So 56 times 2 would be 112. And then to find my remaining arc right here, I could just add up all of these arcs and subtract from 180. So I could do 75 plus 105 plus 112, subtract that from 360, I'm going to get 68. All right, so now I'm going to go ahead and answer my questions. Arc ABC, A to B to C, that's a semicircle, so 180 degrees. A to D to C, that's another semicircle, 180 degrees. Well, I did a lot of work here finding all those missing angles. And arc AMB, that's this guy right here, 75 degrees. If I look at this very last question, if that's 36 degrees, I know that's 36 degrees. And I know this makes a linear pair. 180 minus 180 minus 36 is 144. And because those are central angles, I know those two equal each other. So 10x plus 4 equals 144. So 10x equals 140. So x equals 14.